In section 8.4, we are going to do some application problems that deal with exponential growth and exponential decay. So as you can see up top, we have two formulas. The first one, where it says growth, has an addition symbol, and if it says decay, we're going to subtract. Now, what all of these variables mean, this A is our starting point, or our starting amount. It might be a population, it might be a dollar amount, it might be a dosage of some medicine, but it's what you're starting with. The R is going to be the rate. Now, typically that rate is given to us as a percentage, and we have to change it to a decimal. So we have to remember how to change that, which is just moving the decimal 2 spots to the left. And then this T is time, and it's in the context of the problem. So it might be years, might be weeks, might be days, might be hours. So let's do the first example. Now, it says the first U.S. Census was conducted in 1790. At that time, the population was 3,929,214. Since then, the population has grown approximately 2.03% annually. Draw a graph showing the population growth of the U.S. since 1790. Let's not worry about graphing it right now, but let's set up an equation. So the first part is we're going to use our starting population. Then I'm going to take the number 1 plus this percentage. But I have to change that to a decimal, so I have to move this decimal point over 2 places. So this is going to be 0.0203. Close the parenthesis, and then T is my exponent. And we're going to talk about in years. So now in part B, it says use the equation to estimate the population in those 4 different years. I'm not going to do all those right now. Let's pick 1950. So to put the years in that T, or for that exponent, I have to take 1950 and subtract the starting time, which was 1790. That's going to be 160. So I'm going to take 160 and plug it right into that exponent. So when we do that math, depending on the calculator you use, some might allow you just to type this in all at once. Others, you might have to add the numbers first, take it to the 160th exponent, and then multiply it to your starting amount. If you do that correctly, what I had is 97,896,586 people. Now, in none of these problems are going to tell you what to round to. You kind of have to read the problem and see what makes sense. If we're talking about people, you got to round to the nearest person. If we're talking about money, you got to round to the nearest cent. If you're dealing with some other things, it might just be to the nearest tenth. But just use your best judgment on what to round to.